Hello and welcome. I'm Benjamin Williams, and today we're going to be doing another Boson NetSim lab. Today we're in the security section within Boson, and we're going to be doing NTP security number 2. So our objective in this lab, you will configure network time protocol on several NTP client devices. You will additionally configure each of the client devices to authenticate NTP packets from the master NTP server. Also, you will use access control list ACLs and NTP access groups to restrict NTP synchronization from the master NTP server and to NTP clients. So it says you should allow time for NTP polling interval expirations and several steps in the lab. Of course, NTP takes a while to propagate throughout the network, but it says Boson is a little bit faster than what you would experience on live gear, which is true. Here's our topology that we're working with. We have our router, we have our core switches, we have our distribution switches, or our D switches, and then we have our access layer switches down here. We have some redundancy throughout this network. We have a few connections up to the D switches from the A switches. So if one of these go down, we have another way to get there. Spanning tree is going to take care of the logical loop, so we don't have to worry about that. Same thing from our distribution. Up to our core, we have some redundancy there. We have a port channel between the two D switches. So this ultimately looks like one interface to STP, and we're able to get more throughput because we combine both of these links into basically one logical link. We have OSPF running up here on our distribution and core level layer 3 switches, and they're in area 0, which is the backbone area. And our A switches, we have some PCs connected down to those, and they're in VLAN 100. And we have some computers connected down here to VLAN 200 off of our A switch number 2, and they're in, like I said, VLAN 200. So we've read through all of the commands and the descriptions that we have for this lab. I've looked through the IP address table, and we're going to keep this handy for reference just in case we need it. And let's go ahead and get into our lab task. We're going to do our normal. We're going to do all of our configurations down here at the bottom. We're going to keep our topology up here in the top left, and we're going to be doing all of our instructions on the top right. So let's go ahead and start. It says task 1, configure core NTP clients. So it says, in this task, you will configure NTP on core switch 1 and core switch 2. Router 1 is already configured as the NTP master and has been configured with a time of 8:01 a.m. on June 25th, 2010. So we have our master NTP server is going to be router 1, and we're going to go ahead and do our core switches. So let's go ahead and pull those up, core switch 1 and core switch 2. We're going to be doing our configuration there. So it says, the first instruction, it says, on router 1, display detailed clock information for what source is the time and date set. So it should be NTP. But let's just check. Let's do an enable. Let's do a show clock detail. And we can see that our time source is NTP, and we have a time of 8:12 on June 25th, 2010. So that is good. It says on router 1, display NTP associations. At what stratum is the local reference clock operating? So let's go do a show NTP association, and we can see that the stratum is a stratum 2. It's getting its clock from its local clock, and of course this is the local clock that it's using. It says, what is the importance of the stratum value in NTP? It basically states its authoritative ranking. So the atomic clocks have a smaller stratum than ones that's getting their time from the atomic clock. So atomic clocks usually have a stratum of 0, and then from there, Google's NTP servers will connect to that atomic clock, so they have a stratum of 1, and then so on and so forth from there. So it says, on router 1, display the NTP status. At what stratum is the NTP client on router 1 operating? So let's do a show NTP status. So, okay, so its local clock stratum is 2, but the router's actual stratum is 3. So that makes sense. is operate. So router 1 is operating at a stratum of 3. It says on both core switch 1 and core switch 2 display the current time. Is either time on core switch 1 or core switch 2 synchronized with any time source. So let's see now. Let's go enable privilege exec mode, show clock detail. Oops, detail. So it has no time source, so it's not getting its time from router 1. We know that. On core switch 1, let's do a show clock detail here. And it has no time source as well, so it's not getting its time source from R1 neither. So neither of the core switches are. On core switch 1, configure NTP to synchronize the time with router 1 through router 1's fast Ethernet 00 interface. So let's go up so we can get the IP address of the fast Ethernet 00 interface. Let's go over to core switch 1. Let's go into global config mode, and let's do a NTP context sensitive. Let's do a server, and let's enter 203.0.113.1, and let's hit enter. That's the fast Ethernet 00 connection on router 1. So we just did that. It says on core switch 2, configure NTP to synchronize the time with router 1 through router 1's fast Ethernet 01 interface. Let's go over to core switch 2. Let's give a conf T to go into global config mode, and let's give an NTP server. And let's go up so we can get R1's fast Ethernet 01's IP address, which is, as we can see, is 203.0.113.5. And we're going to go ahead and hit enter there. All right, so we just did step 7. So it says on both core switch 1 and core switch 2, display the current time. Is the time on each device synchronized with the NTP source? Let's go on core switch 1 first. Let's do a do show clock detail here. And we can see that it is getting its time from R1 now. You can see the time source is NTP, and it has the June 25th of 2010 configured. Let's go over to core switch 2 now and do the same thing. Do show clock detail. And we have to give it a few seconds in order for it to synchronize and get up with NTP. So we may have to wait here for a few seconds. Come on, come on. Yep, we're going to have to probably give this a few seconds. Okay, it says on core switch 1, examine the status of NTP. What is the stratum being reported? It should be a stratum level of 4. Let's do a do show NTP status. We can see it is a stratum level of 4. It's getting its reference from R1. Let's go back to core switch 2 now and see if we... Okay, so now it's finally connected up to router 1 with NTP. It has the... time source is NTP now. So now let's go over to, well, we did step 8 and we also did step 9. So it says on core switch 1, examine NTP association. From where is core switch 1 time being synchronized? What stratum of the NTP source? What is the stratum of the NTP source? So the stratum NTP source should be number 3 because that's router 1 stratum, and it should be getting its time from router 1. So let's do a do show NTP association. So we can see that it is getting its time from router 1's fast Ethernet 00 interface. It's using router 1's local clock, and router 1 has a stratum of 3, like we said. So everything is lining up. Let's go ahead and move on to task 2. It says configure distribution and access layer NTP clients. So it says, in this task, you will configure NTP on D switch 1, D switch 2, A switch 1, and A switch 2. Okay, so let's go ahead and pull those up. We need to get D switch 1 up, D switch 2, A switch 1, and A switch 2. So we have those up on screen now. Okay, on D switch 1, display the current time. Is the time on D switch 1 synchronized with any time source? So let's go to D switch 1. Let's go and enable. Let's do a show clock detail. So it has no time source, as we can see right here, no time source. On D switch 1, configure NTP to synchronize time with core switch 1 through core switch 1's fast Ethernet 02 interface. So let's go here on D switch 1. Let's give a conf T to give a global configuration mode. and let's give a NTP server. And let's go up. We want to find core switch 1's fast Ethernet 02. So core switch 1 fast Ethernet 02 has this IP address. So we want to give an IP address of 203.0.113.9. Okay, that's core switch 1's fast Ethernet 02's interface. That's what it wanted. Core switch 1's fast Ethernet 02 interface, just making sure that's correct. Okay. On D switch 2, configure NTP to synchronize time with core switch 2 through core switch 2's fast Ethernet 02 interface. So let's go to D switch 2. Let's give an enable. Let's give a conf T to get in global config mode. Let's give a NTP server. And let's figure out what core switch 2's fast Ethernet 02. Core switch 2 fast Ethernet 02 has this IP address of 203.0.113.21. Let's give an enter there. Okay. Let's go down back to our instructions. Now it says on both D switch 1 and D switch 2, display detailed clock information. Are D switch 1 and D switch 2 synchronizing their date and time with core switch 1 and core switch 2 respectively? So let's go to D switch 1. Let's do a do show clock detail, and hopefully NTP has propagated to this switch, which it has. It's getting its time from core switch 1's fast Ethernet 02's interface. We can see that our date is correct, June 25th of 2010. We have 8:20, and the time source is NTP. That's all we want to see. Let's do a do show clock detail over here on D switch 2, and it is early, so it may have not propagated yet, but it has. So that's good. We see our time source is NTP, same date, same time. Perfect. On D switch 1, display NTP status. At what stratum is the NTP client on D switch 1 operating? So it should be stratum 5, I believe, because core switch 1 should have been stratum 4. So let's do a do show NTP status. Yep, so it has a stratum of 5. And it's operating at stratum 5 because it's getting its time source from a stratum 4 device. All right. On A switch 1, configure NTP to synchronize time with core switch 1's fast Ethernet 02's interface. So let's go to A switch 1. Let's give an enable to get into privilege exec conf T. Okay. Let's give a NTP server. And we want to synchronize with core switch 1's fast Ethernet 02 interface. So core switch 1's fast Ethernet 02 is this IP address, which is 203.0.113.9. That is core switch 1's fast Ethernet 02's interface. Core switch 1's fast Ethernet 02's interface, which is what we wanted. So that's perfect. And it says on A switch 2, configure NTP to synchronize time with D switch 2's fast Ethernet 01 interface. So let's go over to A switch number 2. Let's do an enable and conf T. And let's do an NTP server. And we want D switch 2's fast Ethernet 01. D switch 2 fast. Let me make sure that's right. D switch 2's fast Ethernet 01. So D switch 2 fast Ethernet 01 is right here. And we want to configure it with 203.0.113.22. Perfect. D switch 2 fast Ethernet 01. Yes. So on A switch 1 and A switch 2, display detailed clock information. Are A switch 1 and A switch 2 synchronizing their time with core switch 1 and D switch 2 respectively? So let's go to A switch 1 first, and let's do a do show clock detail here. And it's getting its time source correctly. Its time source is NTP. It has the correct time and date. Let's go over to A switch 2. Let's do a do show clock detail here. And we have to wait a couple of minutes because this time source is not updated to NTP yet. So while we're waiting for that, let's do number 9. It says on A switch 1, display NTP status. At what stratum is the NTP client on A switch 1 operating, and why? So it should be a stratum 6 because it's getting its NTP, is using the NTP server, a stratum 5. So let's do a do show NTP status here. And okay, so it's actually stratum number 5, and it's getting its, okay, that's because it's getting its time source from the core switch, which is a stratum 4. So A switch 2 will probably be a stratum 6. So let's okay, let's do a do show NTP status. Let's see. Yeah, so it's stratum 6. And this is because it's getting its time source from the D switch, which is a stratum 5, and A switch 1 is getting its time from a core switch, which is a stratum 4. So that makes sense. All right, task 3. Configure NTP source security. Cisco devices can use NTP authentication to verify the source of NTP packets. In this task, you will configure NTP authentication on router 1, core switch 1, and core switch 2 so that packets from router 1 are verified by core switch 1 and core switch 2 before core switch 1 and core switch 2 use those packets to synchronize their clocks. So basically, it's just going to authenticate the NTP server. It says on router 1, display NTP association. What authoritative source is being used to synchronize the clock? So it should be using this local clock as the authoritative. I can't say that word right now. It says what author. Okay, I'm getting a tongue twister. So let me just do the command. Let's do a do show NTP. Well, I don't have to do a do because I'm already in privacy set mode. Let's do a show NTP association. So it is getting its reference clock is local. So that's good. So that's the authoritative source. That's what I was trying to say earlier. On core switch 1, display the NTP status. Is core switch 1 receiving its time from router 1? So let's go over to core switch 1 and let's do a do show NTP status. And yes, it is getting its time from router 1. So that's right. It says on router 1, enable NTP authentication. Let's go back to router 1. Let's give a conf t, go into global config. Let's give a NTP authenticate. All right. And it says on router 1, configure NTP authentication key that matches an ID of 1 and a password of $80 $0 exclamation point. How does NTP use authentication keys? Okay, so let's do over here. Let's do an NTP authentication key of 1 and an MD5 password of $80 $0 exclamation point. So how does NTP use authentication keys? So basically, it just makes sure that the IDs of the authentication, it makes sure that the IDs match up. On core switch 1, display NTP association. Is core switch 1 still synchronized with R1? Why or why not? So it should still be synchronized because I don't think it stops it from actually synchronizing. So let's do that. Let's do a do show NTP association. And yes, we're still synchronized, as we can see, because of the star right here and the star right here, which means that we are synchronized. If we weren't synchronized, we would have this little hash saying that we're not synchronized. So perfect. It says on core switch 1, configure NTP to use authentication. So let's go here. Let's do NTP authenticate. And now it says on core switch 1, configure NTP authentication key that uses an ID of 1 and a password of the password that we just entered. So now let's go here. Let's do an NTP authentication key of 1 and a MD5 password. Oh, not an MD5. We don't have to put password. It's MD5 and put $80 $0 exclamation point. All right, that's perfect. It says on core switch 1, configure NTP authentication to trust packets from only NTP devices that authenticate by using authentication key number 1. What will core switch 1 do with NTP packets that claim to be from router 1 but does not use the trusted key? So if it doesn't have the trusted key, it's just going to drop those packets. That's what it's going to do. So let's go on core switch 1 and let's do an NTP trusted key of 1. Enter. So On core switch 1, reconfigure NTP to synchronize over router 1's fast Ethernet 00 interface. You should modify the configuration so that it uses NTP authentication key number 1. So let's do that here. Let's do NTP, and let's do a server. And I'm going to move the topology down to the IP address table so we can just look at that from right here. We need to do core switch 1 fast Ethernet 00. So, okay. It says, no, router 1's fast Ethernet 00. So that's this address. So we want to do an NTP server of 203.0.113.1. And we want to do a key of 1. Perfect. It says on core switch 1, display the NTP status. Is core switch 1 still synchronizing this time from router 1? And it should be, but let's just confirm that. Let's do a do show NTP status, and it is still receiving its time from router 1, which is what we want to see. So that is good there. So perfect. On core switch 2, configure NTP to use authentication. Let's go over to core switch 2, and let's do an NTP authenticate. Perfect. Now it says on core switch 2, configure an NTP authentication key that uses an ID of 1 and the password of this boson. So it says make sure that the password is not identical to the password configured for the authentication key on router 1 and core switch 1. So basically it's just going to show you what happens if you do configure the wrong password. So basically it's not going to sync up. So we have to remove that configuration and then put the right password in. I'm going to go ahead and enter the right password because I already know what we would have to do if I did enter the wrong password. It just wouldn't sync up. So we would have unsynced clocks with NTP. So let's give the right information that we need to do. It says, well, let's just start out on number 13, and then we're going to work our way down until we get to 17, and that's going to have us do the right configuration. So on core switch 2, configure NTP to trust NTP devices that authenticate by using authentication key number 1. So let's do an NTP trusted key of 1. Perfect. On core switch 2, reconfigure NTP to synchronize over router 1's fast Ethernet 01's interface. So router 1 fast Ethernet 01 has this IP address, and we're doing this one right here. So you should modify the configuration so that it uses NTP authentication key number 1. So let's do an NTP. Let's do a server of 203.0.113.5. Let's do a key of 1. Perfect. Alrighty. Now it says on core switch 2, display NTP association. So if we would have did the wrong password, it would not have been associated with router 1. But now, because you can see right here, it says remove the NTP configuration. And then we're going to do on core switch 2, configure NTP authentication, including an authentication key that uses an ID of 1 and a password of the right password. Ensure that NTP attempts to synchronize over router 1's fast Ethernet 01 interface using an authentication key of 1 for authentication. So we already did that. So let's do a an NTP. Let's do an NTP authentication key. We want to do an authentication key of 1, and we want to do MD5 of $80.0 $! Perfect. So now if we do a do show NTP association, we should still be synced up, which we are, to router 1. So that's perfect. Everything is still good. So configure NTP client security. Although NTP authentication verifies the source of NTP packets, it does not prevent NTP clients from synchronizing with other unauthenticated sources. In this task, you will configure ACLs and NTP access groups to ensure that router 1 can synchronize time to only core switch 1 and core switch 2. You will also configure ACLs and NTP access groups on D switch 1, D switch 2, A switch 1, and A switch 2 to ensure that those devices can only receive their time from their existing sources. So it says on core switch 2, display detailed information about NTP association. So let's go to core switch 2. Let's do a do show NTP association. And it says it's NTP on core switch 2 synchronizing with router 1. And it is, as we can see right here. On core switch 2, display NTP. Okay, so we did that. On router 1, create an ACL with an ID of 10 and configure it to permit traffic to match permitted traffic with core switch 1's fast Ethernet 01's interface. Let's go to router 1 and let's do access list 10. Let's permit. And we want to permit core switch 1's fast Ethernet 01's interface. So that's that IP address I just highlighted, which is 203.0.113.2. We're going to give a wildcard mask of all zeros because we want 255s really. Because we're using a wildcard mask. And then we press enter. Okay. Now it says on router R1, configure NTP to synchronize its time only to core switch 1 and to not permit NTP control queries using ACL 10. NTP should not be able to synchronize router 1's time from core switch 1. So let's do an NTP. Let's do a access group. And we want to, it says, do not permit control queries. So we want to do a serve only, a serve dash only. And we want to permit 10. Alrighty. So on core switch 1, display NTP associations. Is core switch 1 synchronizing its time with the router R1? So let's do a do show NTP association. And it looks to be still synced up. It says on core switch 2, display detailed information about NTP association. Is core switch 2 synchronizing its time from router 1? And it's probably not because we just configured that ACL and it did not include core switch 2. So let's see. Do show NTP association. So maybe we have to give it some time to actually not be able to be found. It takes NTP a while. Because right here on number 7, it says on router 1, modify the ACL 10 to permit traffic from core switch 2's fast Ethernet 01's interface. So core switch 2's fast Ethernet 01's interface is here. So let's run this command one more time. Hopefully it's okay. Still showing good. Wow. NTP does take a while, I guess. Everything is still good there. Still good. Yeah. I don't know if... Maybe we got to give it a few seconds. I'm just trying to do all of this in one shoot while I'm recording. But it looks like it's going to take... Okay, finally. So we see that it's unsynced now. With the actual pound symbol that we see here. So it is unsynced. So now we need to go to router 1 and modify the ACL. So let's do an access list of 10. So we're right here. Let me highlight the question that we're on. Access list 10. Let's permit core switch 2's fast Ethernet 01's interface, which is 203.0.113.6. And let's give it wildcard mask of all zeros. Perfect. Now on core switch 2, display NTP associations. Is core switch 2 synchronizing its time with router 1? So let's go back to core switch 2. Hit up. So we're still showing unsynced. Hopefully we get synced back up here in a second. While waiting for that, let's go ahead and move on to question number 9. On core switch 1, configure an ACL with an ID of 10 in the access group that prevents core switch 1 from synchronizing its time with any device other than router 1. So let's go to core switch 1 and let's do an access list of 10, and it wants to permit only router 1. So that'd be 203.0.113.1, and it wants to give a AmeriCard mask of all zeros. And let's do access. Let's do an NTP access group of we only want to peer. It looks like it says configure an ACL with access group that prevents core switch 1 from synchronizing its time with any other device than router 1. So maybe we need to just it says provide only server access. So maybe we need to query only, but I'm not sure. So first, let's go back to number 8. Hopefully we had number 8 right. So let's hit up right here. Okay, so now we see that we're back synced up, which is what we want for number 8. Okay, now we're on number 9 on task number 4. So I'm going to get some help here, just to see how we're supposed to task number 4, and we want to do a serve only. Okay, so we want to do a serve only. Serve only. No, okay, we're on number 9. So number 9, let me go back over number 9. So we want to do a peer. Yeah, so we want to do a peer. Okay, a peer. Alrighty, so we're on number 9, and we want to do a peer here. So group peer, and we want to do 10 for our access group number 10. On core switch 2, configure an ACL with an ID of 10 in the access group that prevents core switch 2 from synchronizing its time with any other device than router 1. So let's go over to core switch 2 and give a similar config. Let's do an access list of 10. Let's do a permit of 203.0.113.5 0.0.0.0. Enter, and let's do NTP access group. Let's do a peer here as well, 10 for the access group number 10. On core switch 1 and core switch 2, display NTP associations. On core switch 1 and core switch 2 synchronizing their times with router 1. So we should be. Let's do an up arrow to do a do show NTP association, and we're still synchronized there, as we can see. And let's do the same thing over here, do show NTP association, and we're still synced up here with router 1. So perfect. It says on router 1, core switch 1 and core switch 2 display detailed clock information of the times consistent across the devices. So let's do a do show clock detail. Okay, do show clock detail, and let's do a do show clock detail, if I can spell. There we go. Alrighty, so it looks like 8:43 there, June 25th, 2010, 8:42 there, June 25th, 2010, and 8:42 there. So yeah, our times are consistent. It says on D switch 1, configure an ACL with the ID of 10 in an access group that prevents D switch 1 from synchronizing its time with any device other than core switch 1. So let's go to D switch 1 now. Give a similar config, access group or access list number 10, permit. We want to permit 203.0.113.9 0.0.0.0. Perfect. And let's do an NTP access group of peer, and let's do 10 for the actual access group. Perfect. Same thing here on D switch 2, configure an ACL with an ID of 10. So we're going to give a similar config over here on D switch 2. So let's give NTP, well, let's do access list 10 permit 203.0.113.21, and let's do a wildcard mask of all zeros. Perfect. Let's give a NTP access group of peer, and let's do 10 for the group. Perfect. Now we're going to give a similar config on A switch 1 and A switch 2, and hopefully everything is going to be done. This has been a long lab, but definitely worth it, and you definitely learn a lot as you go through it. So let's give a similar config here. Access list 10 permit 203.0.113.9 0.0.0.0 for our 22 files for our wildcard mask. NTP access group peer number 10. Perfect. Same thing on A switch 2. Let's do an access list 10 permit 203.0.113.22. Let's give in wildcard mask of all zeros. Access, NTP access group. We want to give a peer and 10 for the group. All right, now let's move on to question number 17 on D switch 1, D switch 2, A switch 1, and A switch 2. Display NTP status. So let's go ahead and do that now. Let's do a do show NTP status here. Do show NTP status here. Do show NTP status here, and a do show NTP status here. Alrighty, are these devices synchronizing with their respective NTP peers? So let's start on D switch 2. So it looks like it is. Same thing here. D switch 2 is. A switch 1, yep, and A switch 2, yep. So on D switch 1, D switch 2, A switch 1, and A switch 2 display detailed clock information of the clocks or the date and time correctly synchronized on each device. So let's do a do show clock. Let's move on over here. Do show clock. Move on right here. Do show clock. And let's move on right here. Do show clock. All right. Enter, 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 enter. So we have 8:47 here, June 25th. Perfect. 8:47, June 25th. Perfect. 8:47, June 25th. Yep. And 8:47, June 25th. So let's grade this. Hopefully we did everything correctly. And we did. So thank you guys for watching this one on NTP Security number 2. I'll see you in the next one.